The sequence xn, where n is greater than or equal to 0, is defined by x0 equals 1, and xn is equal to the sum as k ranges from 0 to n minus 1 of xk for n greater than or equal to 1. The sum as k goes from 0 to infinity of 1 over xk equals 1, 6 over 5, 8 over 5, 3, or 27 over 5. Okay, interesting. Well, so these numbers x are what are called the triangular numbers, right? If I write out the sequence x and xn, so n goes 0, 1, 2, 3, 4, 5. Starting at 1, we just add up all the previous numbers. 1. Oh wait, no, they're not the triangular numbers. Yeah, they're going to be powers of 2, aren't they? 4, 8, 16. Yeah, not the triangular numbers. And this comes from the relation xn is equal to the sum k goes from 0 to n minus 1 of xk. So to get the next number in the list, you just add up all the previous numbers in the list. So xn is then going to be 2 to the power of n minus 1 for n greater than or equal to 1. Yeah, I mean, I suppose we could prove this if we wanted to, right? Conjecture that that's true, show by induction using this formula that that things hold, but I'm not going to bother. I'm not going to bother doing that by induction. This should be pretty clear. Okay, so what we want is the sum as k goes from 0 to infinity of 1 over xk. All right, well, this is the sum as k goes from 1 to infinity of 1 over xk plus 1. So this formula only applies for non-zero values of the index. Okay, so we have 1 plus the sum as k goes from 1 to infinity of 2 to the 1 minus k. Okay, and that's 1 plus, so we take the first term, 1 over 1 minus r, right, when k is equal to 1, where r here is equal to 1/2. That's the geometric series, 1 over 1 over 2. So 1 plus 2 is equal to 3. I hope that's one of the options. Yeah, that's option D. Okay, so the answer here is 3. Other than my terrible little blunder at the beginning, for some reason thinking these were the triangular numbers. I mean, the triangular numbers are the sum of all integers less than or equal to n. But this is different. This is the sum of all previous terms for indices less than n. As soon as you write this out, you can see very quickly that we just get powers of 2, although we have like an extra term in here. And so then writing down the general formula, when n is equal to 4, 4 minus 1 is 3. So you can see, 2 to the 3 is 8, and it should work for all values of n. And then it's really just simple algebra and knowing the formula for an infinite geometric series. So not too much more to say about this one. Thanks for watching.